Welcome back to the final video of the day 1 EcoBrick ratio density exploration. We're zooming into the graphic organizer and then the last set of exercises regarding inequalities, bounded areas on the number line, and certain values, plotting them on the number line, especially when they go into decimal form and past the tenths place. We're actually working in the thousandths place. A number line is a tool we can use to help get ourselves organized, to visualize. What I've done here is zoomed in on the space right in the middle of that number line on your worksheet. 3/10, 4/10, 5/10. Our EcoBricks need to be above a third of their volume in grams. So if our 500 ml volume bottles, a third of that is about 167. Now dividing by 3 here gives us a long repeated decimal, and since our our scale only goes to the whole place, the ones place, then I'm not going to put a ton of decimals here. I'll show you on my numworks how this looks. So if we have 500 divided by 3, you'll see that we get that repeating decimal and it eventually rounds up to a 7. But I can go ahead and round it here instead of letting it continue on and on and on. I can choose where I want to round the last digit up to a 7. And I'll do it at the ones place. A third as a decimal has a similar property as what we saw with 500 thirds. A third is 6 continuous in the decimal values. So we can round that up to a 7th whenever we wish. That's 2/3, I'm sorry. I was carried away by the 6's here. It's a 3 continuous for 1/3. Now, where is this third on our number line? Well, we have 31 hundredths, 32, 33. It's about here a little to the right. So the density of our EcoBricks, the minimum density, is a third. The density must be greater than or equal to a third. 7/10 is the maximum, so it's off of our board, but everything in between a third and 7/10 is viable for EcoBrick construction. So any point that falls within the shaded region is considered to be in the solution set of density and the inequality we form by the bounds of minimum and maximum. The minimum and maximum are inclusive, meaning that it could be exactly at a third or greater, not just greater than a third. Okay, let's plot the rest of them on the last worksheet and see how you do. If you'd like to pause the video and try them out yourself, please do so, and then check your work when you're finished. Let's plot 162 thousandths. Halfway between 1/10 and 2/10 is 15 hundredths. You can imagine that this is 10 hundredths and 20 hundredths. 15's in the middle. We're looking for 162. So I'm going to put the 4 markers in between for 16, 17, 18, 19, 20. This is 160, so a little to the right is our 162 value. This is less than the minimum. This is not an EcoBrick we could build with yet. The next value is 740 thousandths. That's going to be way off the board. Okay, 740 thousandths. I'm going to go ahead and play with 240 thousandths to give you an idea of between which two values we would find that 40 thousandths mark. But you could continue your number line. Your number lines are printed to include the 7 and the 8 tenths. So I'll go ahead and just change it a little bit and do 240. So here's 20, 30. You would find 70, 80. Here's halfway. 25 hundredths. If I'm looking for 240, I'm going to make 4 evenly spaced tick marks to show each hundredth in between. 21, 22, 23, 24, and it'll be right there. For me, I'm doing 240 thousandths. You would be between the 7 tenths and the 8 tenths markers for the 720. 720 is going to be too much. In this case, my 240 is too little. I'm sorry, 740 thousandths is too much. It's above this the 70% density. Not sure if we could use percents there, but we'll look at that in a future video. And I think it works because 100% density would be if I don't know. We'll look into it. You wonder about it. We'll talk about it more. Finally, we have 333 thousandths, which we already plotted. This is our minimum density. And then exactly 400 thousandths, right there. Thanks for tuning in. Stay curious. Stay eco-bricking, thinking about ratios, thinking about density. When you look around, what's more dense, what's less dense? Typically we see less dense things floating and more dense things sort of sinking. Please leave a comment below regarding the densities you see around you right now. How dense is your marker? How dense is your desk? What would float? What would sink in water? Do you think these EcoBricks would float or sink? Let's be curious. Let's keep getting muddy, and let me know if you have a particular video that you'd like to see regarding EcoBricks in the comments below. Also, in the comments below, what do you see around you that you think would float? Let's do that. What around you right now do you think would float? The funny thing is, a lot of things that are orange float. I wonder if you can find something orange around you that doesn't float.